Okay, so quick lesson on calorimetry. Calorimetry is simply using a calorimeter to absorb heat given off by an object to measure how much heat's given off. Here's an example of a calorimeter, and it's pretty simple. Calorimeter starts off with you put your substance in here that you're going to ignite, and you're going to ignite it with the ignition wires, and it's surrounded by water. So what happens is heat always flows from hot to cooler areas. So all the heat that is produced in the reaction is going to flow into the water. And then it's going to change the temperature of the water, which we can find with a thermometer. So now if we have the mass of the water in here, if we have the change in temperature of the water and the Cp of the water, we can now find how much heat energy was given off by the substance. So the key to calorimetry is simply this: heat lost by the substance equals heat gained by the water. Notice I'm using a negative sign for the substance. We're going to do a nail here in just a second. And a positive for whatever absorbed the water. So you guys did a quick write, try to determine what should give off more energy, a red hot nail or a small rock, and that was at about 100 degrees Celsius. So let's go ahead and do that now. You always want to set yourself up with a table like this whenever you're doing calorimetry. It helps you organize your data. Notice we have the substance right here that's giving off the heat, and we have water. And then on the side here, our Q formula. Notice when we're doing this problem, we don't even care about the mass of the nail, the Cp of the nail, or the change in temperature of the nail. We can't exactly measure the change in temperature of the nail directly with a thermometer that we have in the classroom. But it doesn't matter, because heat lost by the nail was absorbed by the water. So we're going to use a very expensive calorimeter, that styrofoam cup, and we're going to fill that styrofoam cup with water. And we're going to fill that styrofoam cup with 100 grams of water. And the Cp of water is 1 calorie per gram degrees Celsius. So it's just 1. And then the change in temperature starts off with 20 degrees Celsius and ends at 22 degrees Celsius. So our change in temperature was 2 degrees Celsius. Therefore, the water absorbed 200 calories. Where did all that come from? It came from the nails. We're going to say negative 200. It lost the heat when we placed it in the water, and it sizzled. So let's try the rock. The rock, you just have to take my word for it on these numbers. All right, so again, for this calculation, we don't care about the Cp of the rock, the mass of the rock, or the change in temperature of the rock. All we care about is the water. So Cp of water is 1. We still have 100 grams, which got some fresh water. Started at 20 degrees Celsius, and this one went up to 23 degrees Celsius. So our temperature change was 3 degrees, mass times Cp times change in temperature. 300 calories. So the winner, the rock. All right, so notice calorimetry. We don't care about the Cp of the object, the mass, or the change in temperature. We just care about the water. But we could, if you're curious, we said the rock was at about 100 degrees, started off that way. The nail, how hot did the nail get? Well, what we can do is this. We can use our Cp formula, Q equals Cp times grams times the change in temperature. And what we're going to do is use our 200 calories that were absorbed by the water to figure out how hot the nail got. Cp of iron is 0.12 calories per gram degree Celsius. And the mass of the nail, I had weighed it, was 1.5 grams. We're going to go ahead and solve for the change in temperature. So we're going to go ahead and we can simplify if we want, but I'm just going to go ahead and do it this way. Those cancel out. 200 divided by 0.12 times 1.5. Change in temperature is going to be 1,100 approximately. Oops. So that nail got a little over 1,000 degrees Celsius, or that was at least the change in temperature of the nail, assuming it started room temperature about 20 degrees. It went up 1,131 degrees Celsius. That's about right. Bunsen burners can get pretty hot. All right, so that's how you do calorimetry problems. Here's another one, if you need another sample problem. A piece of metal weighs 408 grams. At 9 degrees Celsius is placed in 100 grams of water, the water starting at 25 degrees Celsius, the temperature of the water rises to 55 degrees Celsius. So right off the bat, let's see what we're going to calculate the heat loss by the metal. So we're going to set ourselves up with a table. So really, we're going to need the CP of the water, the mass of the water, change in temperature of the water. So guess what? We don't need the CP of the metal, which we don't even know it. We don't need the mass of the metal. We don't need that. And we don't need the change in temperature of the metal. We just need the mass of the water. We need the change in temperature of the water, which is 30 degrees Celsius. And we need the CP of the water, 1 calorie per gram degrees Celsius. So pretty straightforward. $3,000 calories. Okay, so there's calorimetry. Good luck.